Okay, I'm going to show you how my device runs here. This is my toroid coil. It's like 17.5, 18 turns, Cat 5. And this is how it's laid out. The brown wire that says open actually is connected to one leg of the neon, the white wire, and to the orange wire going to the base of this transistor, the small transistor. And the emitter of the small one goes to the base of the TIP 120. That's an MPS 8099. And you can see there's a couple diodes, how I have them configured. And a really interesting one is the other side of the neon lead with the two diodes. It's like rectified. It's coming from the green white wire, or the white green right here. You can see how the primary is bi-filar, and the bottom, the white orange, goes to the collector of the TIP 120. At any rate, you can see the neon's on. I'm only using 28 milliamps, 28.6. Now I have the scope and the frequency counter on. So we're sitting at a baseline right about there. Alright, we have it set on 2 volts variable. This thing runs about 40 kilohertz, but I have this set on 10 times, so that's 20 volts per division. Okay, 28 milliamps, 29, whatever. Now I'm going to show you what the collector to ground, to the negative of the battery. So we're looking at about 38 volt baseline with spikes to 60 volts. Alright, 27.9. Now we're going to go just to the positive of that white green wire. Now look at the spikes on that baby. Now it's showing frequency about 45 kilohertz. We're at 25.43 milliamps. This is at 5 volts. This is a 6 volt battery with the rheostat turned all the way down, and a 25 ohm rheostat and a 10,000 ohm variable resistor here, a linear taper. So 25.3 milliamps, and our spikes are 20, 40, 60, about 75 up to over 100. So yeah, we're about 110 volts at 45 kilohertz, 25 milliamps. As you load it, see, I just took it off. As you load it, the milliamps go down. Neon's still on. I just want to show you real quick what a cheap diode coming out of the collector looks like. That's the signal from the cheap diode, or the switching diode, versus a high speed one. So you got 20, 40, about 55 some, and that's to this little one. Go back to the high speed switching, so you can see the difference here. Alright, one real quick interesting thing. I want to take the ground off of here, or the negative, if I can get it. And what I want to do, if I can do this with one hand, I'm going to connect to keep it oscillating. Also, go to the negative of this. This is that one white green wire and nothing else. Alright, so we still got the neon light on. Nothing's going on. We're at 25.4 milliamps. Now when I hit this, the neon's going to dim a little. And then this is what I'm getting. 22.4 milliamps at about 5 volts. Little 6-volt battery, but it's actually turned down to 5 volts. 22.4, 48 kilohertz. You can see we're getting 20, 40, 50, you know, some baseline, 55 volts, and then over 82 volt spikes. So I'm gonna keep playing with this. This is a good energy recovery system here. 22.3, 48 kilohertz, and it's coming off of the white-green wire on that. At any rate, that is what it looks like right now. Now see, I just took off that and it jumps up. It'll jump up to a different frequency, start using more milliamps when there's no load. See, it's 40 milliamps right now. It's a little bit brighter, but there's definitely all sorts of operating modes this thing going.